So, welcome to this lesson on subnets. As we talked in the previous lessons, subnet is one of the key component of a virtual cloud network. Now, the name itself suggests that it is subnetworks. So, let's do a bit of whiteboarding and then we will move to the slide deck to reinforce what we have learned. So, the first thing that you need to understand is that the VCN can be divided into subnets. So if you have this VCN 10.0.0.0/16, you can divide it into subnets. So in this case, we are just creating two subnets. So subnet A and subnet B. And subnet is also represented in CIDR notation. Because it is a subnetwork, so here we are writing /24, 1.0/24, and this subnet B 10.0.2.0/24. The larger the number, the smaller the network is. Out of /16 and /24, this is a bigger network. And this is a smaller network compared to /16. So also keep this thing in mind. One more thing that you have to understand is that if in a VCN there are multiple subnets A, B, C, and D, each of these subnets are going to have an IP address range. So those ranges, they cannot overlap. I hope you understand the meaning of overlap. If not, let me give you an example. What do you think? Does these two IP addresses overlap? Pause this video for a second and think about the answer. So the answer is yes, they are overlapping. Why? So this CIDR is a part of this CIDR, hence it is overlap. Second example. Now, does it overlap? Again, pause the video and come back. All right, in this case, this is not a case of overlap. And hence, we can have these IP addresses as the IP address range for our subnet. Just like VCN, you can also change the CIDR of the subnet even after the creation of the subnet. Now, one key thing to understand is the fact that if you are inside the OCI region, because some regions have multiple availability domains. So AD1, AD2, AD3. We looked at the fact that a VCN can span multiple availability domains. A VCN always resides in a region. But what about the subnet? The subnet is also of two types. The first one is AD specific subnet. That means the subnet that is created in a specific availability domain. For example, you see this subnet A, it is created inside availability domain 1. Similarly, you see this B created within availability domain 2. And let's say C created within availability domain 3. This is one type of subnet. The second type of subnet that we have is what is known as a regional subnet. And this is typically the choice when you are creating a subnet. this is the best practice, or we can call it as the recommended option. Why? Because this subnet, which is also a regional subnet, it can span all three availability domains in a region. So how is it going to look like? Okay, let me draw it here. So you have a region, you have three availability domains, 1, 2, and 3. So you can create a subnet that can span multiple, let's say it is subnet D, and it can span multiple availability domains. But this will only be the case in a multi-AD region. If your region has a single availability domain, it's one and the same, right? Whether you are creating a subnet in one availability domain or AD specific or regional. When you create a subnet, you typically specify some information. For example, which route table should be associated with my subnet? What should be the security list associated with my subnet? Or what is the DHCP options associated with the subnet? And depending on the options that you specify at a subnet level, all the instances that are part of the subnet, for example, instance A, instance B, instance C, they would basically draw the configuration from the subnet. For example, if default route table is associated with the subnet, then all the routing information that's there in the default route table, that will be drawn by the instances, because instances are ultimately placed in subnets. So that is also a key learning objective. And then we have the subnet types, because we have different types of workload. For example, we have public subnet. We also have the concept of private subnet. As the name suggests, what is a public subnet? A public subnet is a subnet inside which the virtual machine will have both public IP as well as the private IP address assigned to the VNIC. And what is a private subnet? Inside a private subnet, the VM will only have private IP address. So it will not have public IP addresses assigned to the VNIC. That's the case in case of a private subnet. Now, some of the examples. Which type of instances should we deploy in a public subnet, and which type of instances should be deployed in private subnet? Of course, as the name suggests, you can typically very well understand that servers like database servers can be deployed in private subnet, and servers, typically web servers, they can be deployed in a public subnet. When you are creating the subnet, at that point of time, you should make a decision whether you want to make the subnet public or private, because you cannot change it at a later point of time. So while creation of a subnet, just decide whether you require public or private. Now, what we will typically do, as earlier, we will go to the deck and we'll quickly go through the content. because we have already covered most of the things. So now you can visualize it better. So it's an Oracle Cloud region, and then you see the 3 availability domains. There's also a VCN spanning multiple availability domains. Then you see subnet A, subnet B, subnet C. These are AD specific subnets. What you also see here is a subnet D, which is a regional subnet. So we have discussed how a VCN can be subdivided into subnets, meaning a larger network can be divided into smaller networks. So a subnet is nothing but a contiguous range of IPs. And it's also denoted in a CIDR notation. We also looked at this particular point. Each of the CIDR addresses corresponding to each subnet, they cannot overlap. And we also look at different scenarios that helped you understand what do we mean by overlap. Once you create a subnet, you can edit its CIDR. And a subnet can be either AD specific, we have already looked at it, or regional. Now, this is where you see a screenshot where there is discussion around the creation of a subnet. So when you create a subnet, you see DHCP options associated. You see the access of the subnet. It's a public subnet. You see the route table associated with the subnet. You also see the security list associated with a subnet. So therefore, we mentioned it as a unit of configuration. Because ultimately, when you create a subnet and when you create an instance, that instance is going to be placed in the subnet. So all those instances will derive their configurations, network configurations from the respective subnet. So let's now move on to the next slide that depicts the type of subnets. I have already helped you understand what's a private subnet and what is a public subnet and typical use cases of each one of them. As I previously mentioned, while you create a subnet, you have the choice to make it private or public, but you don't have the luxury to change it later. So make a decision during the subnet creation time. With that, we wrap up this lesson on subnets. Hope you enjoyed it. Thanks for watching. In this demonstration, I will show you how you can create a virtual cloud network manually. We will create a VCN. We will give this VCN a name of demo VCN, and we will have the IP CIDR range 10.0.0.0/16. Now, once we do that, we will see that the VCN will be created, but there won't be any subnet because we are creating the VCN manually. But we will see that there will be a route table that will be created. There will also be a default security list that will be created and a default DHCP option that will be created. So let's go ahead and create the VCN manually. So I am inside the OCI console. I'll click on the navigation menu, click on networking, click on virtual cloud networks. So there are two options, as you can see. The first option here is when you would like to create the VCN manually. So I'll click on create VCN. I'll give it a name, demo VCN. This is where I will create it. This is basically the compartment name. And IPv4 CIDR blocks and I can press enter to add this particular CIDR block. One thing that you will notice here, you can have up to 5 IPv4 CIDR blocks, but there must be at least one IPv4 CIDR block. I will go with use DNS hostnames in this VCN, the default option. I'm not going to assign an IPv6 prefix. I'll click on create VCN. So you see, the VCN is now created. Now under resources, there is a route table that is created. There is also a default security list, and there is a DHCP option. And of course, as we defined the CIDR block, which was 10.0.0.0/16, so we are also able to see that. So this marks the end of this demonstration. Thanks for watching. In this demonstration, I will show you how you can create a VCN using VCN Wizard. So let's get started. I'll take you to the OCI console. I'm already logged in there. So I'll click on navigation menu, go to networking, go to virtual cloud networks, and I'll click on start VCN Wizard. Now there are two options here. The first is create VCN with internet connectivity. This is the one. And the second option is add internet connectivity and site-to-site VPN to a VCN. So what happens if I go with this first option? This option is going to create a VCN for me, as you can see in this diagram. It is also going to create a public subnet as well as a private subnet. Instances in the public subnet can connect to the internet using Internet Gateway, whereas instances in the private subnet can connect to the internet using NAT Gateway. And then there is also a service gateway that is going to be created to connect privately to the Oracle Services Network. Now this is a kind of wizard. You don't need to configure everything manually. You just select this option and this wizard is going to take care of provisioning these all services. The second option is where it will basically create a site-to-site VPN between your on-prem network and VCN. You can also see the components that are going to be created. So for the sake of this demonstration, I will go with create VCN with internet connectivity. Click on Start VCN Wizard. I just need to provide the VCN name, OCI a VCN. I am okay with this compartment. I am also okay with this CIDR. Then you see that it has automatically selected an IPv4 CIDR block for your public subnet as well as private subnet. If you want, you can change this, or you can also keep it as the default. Click on Next. Just review the configuration and click on Create. So this is actually a good visualization of what all things were created. So as you can see, a VCN was created. Two subnets were also created along with Internet Gateway, NAT Gateway, Service Gateway, and a route table was also created for private subnet. Security list was also created for private subnet, and then it updated the route tables and private subnet. So let me click on View VCN. Now I can see that there are two subnets, private subnet and public subnet. If I go to the route tables, you see that apart from default route table, there is also a route table for private subnet that has been created. There's also one internet gateway, NAT gateway, and service gateway that has been provisioned for me. If I look at the route rules, there is a route out to the internet. And if I look at this particular route table, which is for private subnet, there will be a route out to NAT gateway and service gateway. So this is how you can create a VCN using the VCN wizard, and the service is going to automatically provision the components for you. So with this, we are concluding this demonstration. Thanks for watching. All right, let's talk about route tables in this lesson. So let's get started. So let me first bring up the whiteboard and talk about some aspects of the route table. First of all, route table is going to determine how the traffic is going to flow inside the VCN, and when the traffic originates from the VCN, how the traffic is going to flow. Route table in a way also defines the path for destination. And typically, there are two types of route tables. The first one is the default route table. This one is automatically created. So whenever you create a VCN, a default route table is going to be automatically created. I'll talk about the rules that it is going to have, but before that, let me also talk about the second type of route table that you can have, which is a custom route table. So this is typically a route table that you create. So two types of route tables. This default route table has a rule which is implicit. What that means? Let's suppose this is a VCN, subnet A, subnet B, subnet C. So three subnets inside the VCN. I mentioned whenever you create a VCN, you are going to get this default route table, and this default route table will have a local rule. That means all these subnets are going to be associated with this default route table. This also means that they can communicate with each other, and there is no requirement for any type of rule to be added in order to establish the communication between the subnets inside the VCN. Now the question is, why is this so? This is so because the default route table contains a local route, and therefore I mentioned it is implicit. If you go to the route table, you will not be able to see this local route. You will feel like the route table is empty, the default route table, but it is not empty. It has a local route which facilitates communication between the subnets or the instances within the subnets to talk to each other. So that is the significance of this local route and default route table. Now the second thing is custom route table. In custom route table, again, when you are creating it, you can give it a name. And after giving it a name, when you click on create, it will again create a route table, again have the implicit route. That means whether it is default route table or custom route table, it is going to have the local route. Why do you require to create a custom route table? Because in your VCN, we have mentioned that there can be two types of subnets. One can be public, the other one can be private. And to influence the routing of each of these subnets, they typically cannot be associated with a single route table. Hence, we can create custom route table and associate it with, let's say, our public subnet. All right, if this is clear, then we will move on to look at how the route table actually looks like. So there are two columns in a route table. One is the destination CIDR block, and the second column is the target, which is typically the next hop. So this is how it's going to look like. So here you will have the CIDR block. And here you'll specify where do you want to send it. A very simple example. This is a VCN. Inside that we have one subnet A. This is internet. And this is basically the internet gateway. So there is an instance over here that wants to talk to the internet. What should be specified in this destination CIDR block? The CIDR range of the destination. In this case, the destination is internet. And we can specify the CIDR range of the internet as this 0000/0. Now, if that is the internet, where do you want to send the traffic to? Or what is going to be the next hop? It is going to be internet gateway. Therefore, we'll provide internet gateway here. This was just one of the examples, just to show you how this route table looks like. And then we can have different types of targets in this route table. Internet gateway was one of the examples. When we will review the slide deck, I will show you some other options as well. Some other allowed types of target for a route rule. Just to mention a few, it can be service gateway, it can be NAT gateway, it can be dynamic routing gateway, it can be local peering gateway, it can be a private IP, right? I will show you that list. But I hope you understand what is a route table and how does it look like. Thanks for watching. So now let's go to the deck and review some important information. First of all, the route table basics. As I already mentioned, route table defines the path for the destination. It determines how the traffic is going to flow. And specifically, when you are sending the traffic out of VCN, because local traffic is anyways taken care by the local route in the VCN. Another important objective or learning objective is that inside the VCN, we can have different subnets, right? For example, subnet 1, subnet 2. A route table is always associated with a subnet. Now, there is one key learning objective here that you need to understand. One subnet can be associated with only one route table, but the same route table can be associated with multiple subnets. For example, we have the default route table. It can be associated, if there are 3 subnets, it can be associated with 3 subnets. But let's say you have 2 route tables. This one is the default route table, and this one is the custom route table. And let's say there are 2 subnets, subnet A and subnet B. Now, it cannot be the case where one subnet is associated with both the route tables. This configuration is not possible. What is possible is one subnet can only be associated with one route table. So if you have this in place, this cannot be the case. But the reverse is possible. Each route table can be associated with multiple subnets. And that is the case when we talk about default route table. I also talked about the local routing and how it enables communication between the instances in different subnets inside the VCN. All that is possible due to the VCN local route. This one is again key, and I have to take use of whiteboarding to explain you this. How does the most specific rule win in case of overlapping rules? First of all, what is the meaning of most specific? Let me provide you 2 IP addresses. This is the first, and this is the second. Let's say in this case, I provide. Can you tell me which is the most specific in this case? This is generic. This is specific, right? So this one is most specific. Another example. This time it's a representation. VCN, subnet, internet, and let's say this is an Oracle services network. Typically, let's call it object storage. Now, if there is a route table that is associated with this subnet, this is the destination CIDR, this is the next hop. And here, if the CIDR range of object storage is specified. So here basically there are 2 entries. One is 0000/0, and here we are calling it internet gateway. And here, because this is also a public service, Oracle Services Network, and object storage service will have its own range of IP addresses. Let's say it is mentioned over here, right? In this case, we want to have service gateway as the next hop. Now you tell me, because this is a part of this, because 0000 denotes everything, anything in internet, right? And this public IP address will obviously be a part of this or the subset of this. So in this scenario, what do you think is going to happen? If the traffic is originating from here, should it go to the object storage through the internet gateway or the service gateway? It will choose the service gateway. Why? Because it is most specific, right? It is most specific. That is what is the meaning of most specific. I hope you understood this concept. This is very critical. and therefore I took some time to explain it. Most specific rule wins in case of overlapping rules. All right, now let's move on. And in case there is no matching, then the traffic is going to be dropped. That is also a key learning objective. So let's look at the route table and how it looks like. So as I mentioned at the very start, there are two types of route tables that we can have. One is the default route table that gets created automatically when you create a VCN. The second is the custom route table. You can create it whenever you need it. One interesting thing that you can see here is that in the default route table, the number of rules says 0. Although there is one implicit rule, the local route, but it does not say 1, it says 0, right? Just make a note of that. And we have also seen that each rule will specify the destination CIDR and the route target. Now this is a key diagram here. Here there is a VCN, there is a public subnet, there is a private subnet. This is what you see as the route table. All right, for the database systems, in case they want to download some patches from the internet, they will use NAT gateway, and the same information is going to be provided in the route table. In case this wants to interact with object storage, that needs to be done. The next hop in this case is going to be service gateway. Similarly, instances in the public subnet, in case they want to interact with the internet gateway information needs to be there in the route table. And just to show you an example, for the private subnet, this is how the route table will look like. If the destination is 0000, send it to NAT gateway. If we want to go to the object storage, which is part of the Oracle Services Network, so object storage, if that is the destination, go to service gateway. And this was the same example that I took for explaining you the specificity, right? Now, in case traffic from here originates and wants to go to object storage, that can also fall here. But this is most specific, and hence it will go to this via the service gateway. Now, during the discussion in whiteboarding, I mentioned that I am going to show you the list of all the target types that are supported in the route rule. Local peering gateway, service gateway, dynamic routing gateway, internet gateway, private IP, NAT gateway. These all are valid targets for a route rule. Very quickly, if I would like to talk, internet gateway. Typically, it will be there as a target in case of public subnets that need direct access to the internet. NAT gateway, this will be there in the route table for private subnets in case the instances in the private subnets want to download something from the internet, and that is going to be unidirectional, not bidirectional. Service gateway, I have already explained you. In case the subnets need private access to Oracle services like object storage. Local peering gateway, we'll talk about this concept in the upcoming lessons, concept of local peering, remote peering. But at this point of time, just understand that within the same region, if you are talking to another VCN, basically you have peered with that VCN and you need access. So I'll put it there. Then there is dynamic routing gateway. This has to do with communication between the on-premises network and your VCN. And then there is private IP. Private IP, in case you need to route traffic to an instance in the VCN. In that case, you can also have private IP as the target type. So that was it. That's about route tables. Thanks for watching. In this demonstration, I am going to show you how you can work with route tables, how you can create a new route table, and how you can add a route rule in the route table. So let's get started. Let me take you to the OCI console where you can see these two virtual cloud networks created in our earlier demonstrations. So just to show you how a route table looks like, let me click on this particular VCN. And then under resources, if I click on route table, you see there are two route tables here. There's one default route table and then this route table for private subnets. So this VCN was created using the wizard, and hence you are able to see the two route tables. And you can also see the number of rules that each of these route tables have. Now let me go to Virtual Cloud Networks and go inside the demo VCN. So this is the VCN that we have created manually. If I go to route table, here you will only be able to see one route table, which is the default route table for demo VCN. The state is available. The number of rules is important here. There are no rules as of now. So if I go inside this route table, you will see that there are no rules. But technically, there is one implicit local routing that is not visible here. And using this local routing, all the instances within the subnets inside the VCN will talk to each other. For example, this is subnet 1, this is subnet 2, and this is our VCN. So if instances within subnet 1 and instances within subnet 2 want to communicate, they will typically do that using local routing. So the communication is handled by VCN's local routing, but you are not able to see it here. Now, how do we add a route rule? So before we can add a route rule, let me do one thing. Let me first of all create a subnet. So I am creating a private subnet. I'll keep everything as default. I'll just provide the CIDR block. I'm creating a private subnet. I'll click on create subnet. Now, I will also go ahead and create a NAT gateway. We are going to see the demonstration of NAT gateway in the upcoming demos, but to show you the functionality of the route table, I need these gateways. So everything default, I just specified the name and click on create NAT gateway. Okay, so the NAT gateway is successfully created. Now I can go back to the route table. First of all, let me show you how you can add a route rule to an existing route table. So this is my default route table, and now I am going to add a route rule. When you are adding a route rule, you have different choices that you can make for the target type. You can select dynamic routing gateway, internet gateway, local peering gateway. In our case, we are going to select NAT gateway, but you can also have private IP and service gateway as the valid target types. So I'll select on NAT gateway, and then you need to specify destination. Destination basically reflects where are you sending the traffic to? Where are you sending the traffic? And then this target type, this basically denotes next hop. You are going to define the target type here. This is the type, and this is going to be the actual gateway. So if you are sending the traffic to, let's say, internet, then here we will provide 0000/0, and here we will provide the NAT gateway that we created. So let me provide the destination CIDR. I have provided this as the destination CIDR, and then my target NAT gateway, as I have already created one, this is going to be the target NAT gateway, and click on add route rules. So this is how you add route rules to your existing route table. In this case, we added a route rule to the default route table. But what if we want to create a route table? So click on create route table, give it a name, custom route table, and then while you are creating a route table, adding a route rule is optional. So click on create. So you'll have the custom route table. Again, the number of rules is showing 0, but also understand that this custom route table also has a local route that is implicit. So be it the default route table or custom route table, you are always going to have the implicit local routing. And in the similar way, you can add your route rules. For example, this time you can select Internet Gateway and then provide CIDR, select the available Internet Gateway and click on Add Route Rules. So you can do that. The next thing that I'm going to show you, because I already have this particular route table, 2 route tables created. Now, if I go to the subnet and let's say I want to associate a route table to a subnet. By default, any subnet that you create inside the VCN, you see we have created private subnet inside this demo VCN. By default, it is always attached to the route table. So how do we change it? So we'll click on edit. And here I'll click on custom route table. Click on save changes. Now you see that this is updating. And in some time, you'll see that the route table has actually changed for the private subnet. So this marks the end of this demonstration where we looked at route tables. Thanks for watching. Hello and welcome. It's time for gateways, and the first one on the list is Internet Gateway. Let's try to understand what an Internet Gateway is, starting with whiteboarding. This is a VCN, and this is Internet. One more time, I'll draw it. Okay. Now, see the direction of the arrow. And in this case, the direction of the arrow is this. First of all, you need to understand that if the direction of the arrow is pointed towards VCN, that means traffic from internet to VCN, then we basically call it ingress traffic. Typically, it's ingress to VCN. And if the traffic is flowing out from VCN to internet, we call it egress. The intention where I created these two diagrams is to illustrate the fact that an internet gateway supports both these configurations. It supports ingress as well as egress traffic. The next thing that you should understand is that VCN, if VCN is a construct and you would like to enable direct connectivity to the internet, then the gateway that you can add to the VCN is the internet gateway. But to use the gateway, there are some conditions. who can send traffic to internet? So for that to occur, the instance must be in a public subnet. So this particular instance is in a public subnet. This particular instance must have a public IP. And then the subnet in which the instance resides must have a valid route table entry pointing to internet gateway. For a VCN, you just need one internet gateway. So only one internet gateway is needed for each VCN. So this is pretty straightforward. It's a managed service. You don't need to worry about its scaling or its high availability or its fault tolerance. Oracle Cloud Infrastructure is going to take care of these things. Now, let's go through the deck. It should be pretty quick. So using internet gateway, you can talk to the internet. So it basically enables bidirectional communication. Even the instances in the internet will be able to talk to instances within the VCN. So it's a bidirectional communication. And it also enables direct connectivity to the internet. I have already explained you in the whiteboarding section that it supports both egress, that means traffic originating from VCN towards internet, as well as ingress, that means traffic originating from internet to your VCN. So it supports both the traffic. And because it's a managed thing, right? You don't need to worry about creating multiple internet gateways. Actually, you cannot create multiple internet gateways for a VCN. So only one internet gateway per VCN is what you need. Now, this is just to show you how you can have internet gateway as one of the route target in the route table. For this example, focus on the public subnet, because when we talk about the private subnet, internet gateway is not relevant. We'll talk about NAT gateway in the upcoming lesson, but for now, just focus on public subnet. You have a virtual machine inside a public subnet that wants to talk to the internet. And also focus on the directions here. This thing points to bidirectional traffic. Bidirectional. So this VM wants to talk to the internet, and this VM is currently deployed in a public subnet. This VM also has a public IP associated with it. It's not represented here, but this is the CIDR of the public subnet. But this VM also has a public IP address associated with it, and it's deployed in a public subnet. What this VM also has is that because it is deployed in a public subnet, there is a route table associated with the public subnet where there is a route out to the internet through internet gateway. Now, these are the three conditions. Apart from that, just to caution you, you also need to take care of opening the ports. I'm not talking about that right now, but in the subsequent lessons, we have dedicated lessons on security list and network security group. That is also important. The routing is fine. All right. The VM has a public IP. No worries. The VM is in public subnet. No worries. But you also need to have the ports opened in order for the communication to be successful. So keep a note of that. I'm talking about the security rules. Okay, so the destination is 00, the route target is internet gateway. So that is what I wanted to show you very quickly. And that marks the end of this lesson on Internet Gateway. Thanks for your time. Hello and welcome to this demonstration on Internet Gateway. Let me show you what we are going to do in this demo. So in the VCN, there are two subnets. One is private, the other one is public. We'll create a compute instance in the public subnet. And what we will also do is we will add an internet gateway, and then we will update the route table to add the route out to the internet through the internet gateway. And then we will associate this particular route table with the public subnet. And then we will see if this particular VM is able to reach out to the internet or not. So let's get started. So I'm inside the OCI console. The very first thing that I would do is I'll show you the configuration. Go to demo VCN, and you see there are two subnets, private and public. I see only one route table. So let me create a public route table. Click on create. I'm also not able to see the internet gateway. So very quickly, first let's create the internet gateway. So to create an internet gateway, you just need to specify a name and that's it. Just select the compartment, click on create internet gateway. Now just to show you another learning objective, if I try to create a second internet gateway, it will throw an error because one VCN can be attached with one internet gateway. Okay, so now that we have the internet gateway, we will go to the public route table and we'll add the route rule. The target type is going to be internet gateway. The destination CIDR block is going to be 0000/0. And in the target internet gateway, select demo IGW. Click on add route rules. Okay, so all set. Now let me go to the compute instance, quickly provision an instance in the public subnet. Okay, so I'm okay with the compartment. Everything else remains the same. The only difference is I'll select demo VCN and I'll select public subnet. Automatically assign public and private IP addresses. And regarding the SSH keys, let me grab it very quickly. So I already have the key pair. So I'll just paste the public keys. Rest everything remains the same. Click on create. So I'll wait for the compute instance to get provisioned, and then we will connect to the instance. So we see that this instance is now created. So before we connect to this instance, let's try to verify whether the subnet in which the instance is placed is associated with the correct route table. So very quickly, let me go to the VCN, demo VCN, public subnet. You see that the public subnet is associated with default route table. So we need to change this and we will make it public route table. Click on save changes. You see it is getting updated. So it's all done. So return back. This is the public IP address. Let me try to do an SSH. Okay, so it works. So you see that now I am inside this virtual machine instance. First, from within the instance, I'll try to reach out to the internet. So let me try reaching out to oracle.com. Okay, so this works. If I try to ping, see, I'm able to get the response. Okay, so I am able to reach out to the internet. All right, so we see that the ping is working. This marks the end of this demonstration. Thanks for watching. Hello and welcome. Let's talk about NAT gateway now. The very first thing that I would do is explain you why we require NAT gateway. Basically explain you the purpose of a NAT solution. NAT stands for Network Address Translation. And the main purpose of NAT is to give instances in a private subnet access to internet. And that is the purpose of a NAT gateway. So let me draw a VCN. In the VCN specifically, I am drawing a private subnet. So this is the representation. Inside that we have an instance, and this is your internet. So to give this particular instance access to internet, that is the purpose of a NAT gateway. Now there are 2-3 important things that you should know here. The first critical thing is instances in the private subnet, they can initiate connections to the internet. Along with that, they can also receive responses. So responses of what? Responses of the connection that they have initiated to the internet. So that is allowed. But what is not allowed is the inbound connection request. So let's say these instances in the private subnet, they receive inbound connections that is initiated from the internet. This is not allowed. This is allowed. So they can initiate connections to the internet and receive the responses, but when they receive inbound connections initiated from internet, that is going to be denied. So it's unlike internet gateway, it is unidirectional in nature. Now the other thing is, for this outbound traffic, outbound to the VCN, because these instances, they don't have public IP address. So what is going to be the source IP in case of outbound request? It is going to be the NAT device. In our case, the NAT gateway, it's public IP. So what it also means is that whenever you create a NAT gateway, a public IP address is going to be assigned to the NAT gateway. Now, talking about the kind of traffic that is supported, it supports TCP traffic, ICMP ping traffic, and UDP traffic. All right, now I will talk about one more interesting thing before I jump to the slide deck, and that is the capability to block the traffic when it comes to NAT gateway. So let's say you created the NAT gateway and then you would like to block the traffic flowing through the NAT gateway. To help you do that, there is a functionality. After you create the NAT gateway, you can go ahead and you can block the traffic. So what happens is, regardless of any route rule or any security rules that you have in the VCN, all the traffic that flows through the NAT gateway is going to be blocked. So this is one interesting feature that NAT gateway has. All right, now let's go to the deck. You know that when we deploy instances in a private subnet, all they have is a private IP address. They don't have a public IP address. And in case they want to communicate with internet, they directly cannot because they don't have public IP address. So therefore, we have the concept of this NAT gateway, and NAT gateway is going to provide the instances in a private subnet access to the internet. One key use case here is the database servers that are deployed in the private subnet. In case they want to download some patches from the internet, they can use this NAT gateway. So this is one of the use cases. We have already discussed that they do not allow connections that are initiated from the internet. So that is going to be denied, rejected. But they can receive responses for the connections that they have initiated to the internet. That is allowed. I also talked about the supported traffic, which is TCP, UDP, and ICMP ping traffic. And it's also a managed solution. Previously, there used to be NAT instance, but we have NAT gateway now. It is highly available. So let's move on to the next slide where there are some data points. The first data point is with respect to the number of concurrent connections. The number now is 20,000. So it's good to know. Now, when I was talking about the outbound request, I mentioned that because the private instances do not have a public IP address, so what is going to be the source IP that is going to be reflected in the outbound request? That would be the NAT gateway's public IP address. And therefore, when you create a NAT gateway, you have two options. You can either go for ephemeral IP address. Oracle is going to assign an IP address to the NAT gateway, or so first option is ephemeral. The second option is reserved. As the name suggests, ephemeral is not permanent, all right? But if you have reserved your IP address, then you can also assign it to the NAT gateway. So you have both these options. And this is going to be a public IP address. Unlike the instances that are deployed inside the private subnet, they don't have public IP. All they have is a private IP. Okay. Now, routing for a NAT gateway. This is also interesting because in your VCN, you have a private subnet, and then you would like the instances in the private subnet to talk to the internet. So therefore, these subnets must be associated with a route table that has a route out to the internet through the NAT gateway. And then another key thing here is a NAT gateway can be used by only the resources in the gateway's own VCN. Now, this is very important. Why? Let's say your VCN is connected with another VCN, and we'll talk about that. That is peering, right? In the upcoming lessons. Let's say it is paired with another VCN. And let's say this has a NAT gateway, and there is a resource here, private instance. Now, does it mean that the resources in other VCN can access the NAT gateway or can access internet through the NAT gateway? No. Similarly, if this VCN is connected to your on-premises network, even the resources in the on-prem network that is connected to the VCN, they cannot use the NAT gateway. The conclusion is simple. A NAT gateway can be used only by resources that exist in the VCN to which the NAT gateway is attached. And if we look at the architecture on the right, this is the private subnet, this is the database system. These database systems or servers, they want to communicate with the internet, and you see the direction of the arrow, it's unidirectional. So they can do that through NAT gateway. But instances here, they cannot initiate the connection and reach to the database system. And that is what we need. And therefore, we have put the database servers in the private subnet. That marks the end of this lesson. Hope you are having a good time learning different concepts of networking. Thanks for watching. In this demonstration, I will show you how to create a NAT gateway. So let's get started. So I'm inside the OCI console and I can see the virtual cloud networks. So let me go inside the demo VCN, and under resources, I see that as of now, there is no NAT gateway. So click on NAT gateways, click on create NAT gateway, give your NAT gateway a name, select the compartment, and then there is an important choice that you have to make. You can either go for ephemeral public IP address. So this is a kind of temporary IP address that is assigned to the NAT gateway till the lifetime of the NAT gateway. So after you terminate the NAT gateway, this IP is going to be released. And then there is another option where you can go for reserved public IP address. So here you control the public IP address lifetime. So I will go with ephemeral public IP address. And in this option, Oracle is going to generate an IP address for my NAT gateway. So click on create NAT gateway. So our NAT gateway is now created. You can see the state as available, and you can also see the public IP address that is assigned to this NAT gateway. And this is an ephemeral IP address. Because we already have the NAT gateway, what we can do, we can go to the route tables, we can go to default route table, add route rules. The target we can make NAT gateway, the destination is internet, and then we can specify this NAT gateway that we created. Click on add route rules. So the next step is going to be associating this default route table to any private subnet. So that's it. This marks the end of this demonstration where we looked at how we can create a NAT gateway, and it's a pretty straightforward process. Thanks for watching. Hello and welcome to this lesson. In this lesson, we are going to talk about service gateway. So let me explain you what is a service gateway. Let me first talk about a construct which is known as Oracle Services Network or OSN. So Oracle Services Network is basically reserved for Oracle services. And these services, they have public IP addresses. So typically, when you try to access these Oracle services, you will typically reach those services over internet. However, if we use or if we leverage service gateway, then the cloud resources that don't have public IP, that means cloud resources, even with private IP addresses, they can reach out to these Oracle services, and that communication is going to be private. So basically enabling private access. And the best part here is your hosts in VCN, they can privately access Oracle services network. And when I say private access, the traffic is never going to traverse over the internet. The traffic is always going to travel over Oracle Network Fabric. Now, you may wonder, why are we so concerned about privately accessing the Oracle Services Network? Because it all boils down to not exposing data when the traffic goes over the internet. Let me now talk about a concept which is known as services CIDR level. So this services CIDR level is basically a string which represents all regional public IP address ranges. See, there are two ways. The first way is, because I mentioned all the services, all the Oracle services in Oracle Services Network, they have public IP addresses. And that is basically a range. It's not a single public IP address. So one way of using those ranges is you manually put the public IP address ranges. Now, the problem with this approach is, if the service public IP address change, you might have to adjust different things. For example, routing, it can be in security rules, it can be in route tables. So everywhere you have to manually adjust. But if you are using a string that corresponds to the public IP address ranges, then you don't have to make those adjustments. So that is the benefit of using services CIDR level. And one of the examples that you can think of is, let's say, OCI Phoenix object storage. So this is how the string looks like. This is how the services CIDR level looks like. Now let's move to the deck and talk about service gateway. As I mentioned, Oracle Services Network is reserved for Oracle services. And typically, how do we access those services in the OSN? Typically, we reach those services over the internet because these services, they have public IP addresses. But is this the best practice? No. The best practice is to access those services privately without exposing the data. And that is where the service gateway comes into action. So using the service gateway, you can access the Oracle services privately, wherein the traffic travels over the Oracle network fabric and it never traverses the internet. So it's a kind of secure and private path for your network traffic because the communication happens over the Oracle network fabric. The best part about this is the hosts in VCN, they don't need to have public IP addresses. they can only have private IP addresses, still they can access the Oracle services in Oracle Services Network. What it means is you don't need an internet gateway, you don't need a NAT gateway. So even without these gateways, just by using Service Gateway, you can access those services privately. Now let's look at this particular architecture. Here we are concerned about private subnet because there are servers that are deployed in the private subnet. These servers, they don't have public IP address. All they have is a private IP address, and then they want to access object storage service, which is part of Oracle Services Network. So here we have deployed a service gateway, and we have also made the corresponding changes in the route table. This is the route table for the public subnet. I'm not going to discuss about that. But if you look at this particular route table, you see that in case this wants to talk to internet, the route target or the next hop is NAT gateway. But in case these servers want to communicate with object storage services privately, then we have this route target as service gateway. Remember, this destination CIDR, usually it is the range of IP addresses. In the previous lessons, you might recall, here we put the destination CIDR, for example, 0000/0. But in case of Oracle services in Oracle Services Network, as I mentioned in the discussion, we use services CIDR level. And I also gave you an example, OCI PHX for FINX, and then object storage. So rather than manually entering IP addresses here, just use services CIDR level and then just define the route target. So that is what is your service gateway. And one last point is this is also regional. That means it is going to enable access to supported Oracle services in the same region because it is a regional service. So that marks the end of this particular lesson where we looked at why use Service Gateway. Thanks for watching. Welcome to this demonstration on Service Gateway. Let me walk through a scenario that we are going to cover in this demonstration. So I'm going to have a VCN. Inside the VCN, there will be a private subnet. And inside the private subnet, there is going to be a virtual machine instance. And this virtual machine instance, keep in mind, is inside the private subnet. So it will just have the private IP address. Now, I'm also going to have a bucket and then on the VCN side, I will have two types of gateways. The first is NAT gateway. Then I will have service gateway. And I will explain you the purpose why I am creating these two types of gateways. And then I also need to configure route tables and security lists on the VCN side. What I will then do is I will connect to this virtual machine instance. And this part is also interesting because this VM instance does not have a public IP address. So I will make use of something that is known as private network definition list. So it is one of the features that we have in Cloud Shell. So I will make use of this feature to connect to this particular virtual machine instance. After that, I will install CLI. For that, I require NAT gateway. After that, I am going to remove the NAT gateway, and then I will show you how we can upload an object here. So I will run a command to upload an object in the bucket. The intention is to show you how we can make use of Service Gateway to interact with Oracle Services Network. So I hope the scenario is clear to you. So we will go step by step. So let's get started. The very first thing that I will show you is what resides inside this demo VCN. So inside this demo VCN, there is a private subnet. As of now, there is a route table, the default route table that is created. There is an internet gateway. We don't require it for this demonstration. And we don't have anything else. So the very first thing that I would do is let me create a service gateway. So I'll give it a name. I'll select the compartment. And for the sake of this demonstration, I will use OCI Phoenix Object Storage. Click on Create Service Gateway. Okay, so this has been created. Let me also create a NAT gateway. I'm okay with ephemeral public IP address. Click on Create NAT gateway. Now, what I will do, I'll click on Add Route Rule. I'll select the target type as NAT gateway and the destination CIDR as internet 0000/0, which means internet. And I will also select the NAT gateway that I created. Click on Add Route Rules. And very quickly to show you, if I go to this private subnet, you can see that it is associated with the default route table. Okay, so now the service gateway is created. I have configured the route table. We have also created NAT gateway. Now it's time to visit object storage service. Let me show you how to create a bucket. So I'll very quickly create a bucket. Rest everything remains the same. Click on Create. So we will upload objects inside this bucket, but we will not do that now. Before we do that, let me create an instance with the name demo instance service gateway. Okay. I'll keep everything as the default. The only thing that I would do is I will select demo VCN and then the subnet is going to be private. Okay. And I also need to paste the public keys. So let me bring up the Cloud Shell and generate the key pair. Let me just copy the public key. So I just need to copy it. And put it here. Folks, this is a demonstration on Service Gateway, but since most of you might be following along with me, I am creating it end to end from scratch. For this demonstration, we require a compute instance. Hence, I am creating a compute instance. I'll click on create. And in the meantime, this is getting created. What I also need to do is I need to create a private network definition list. So I'll click here. I'll click on private network definition list. I'll click on private network definition. I will name it Service Gateway Demo. I'll select the demo VCN and then I will select the private subnet. Click on create. So now you can select your default network description and click on close. So now you can go ahead and you can mark this Service Gateway Demo network definition to be used as an active network. So click on use as an active network. And now you will see that this is actually getting connected to the private network definition list. Okay, so we will wait for it. In the meantime, I see that my private instance is now running and it does not have a public IP address. It has a private IP address. So we will use this private IP address to connect to this instance. Okay, we see that now it's connected. We will do a SSH. OPC is the user and the private IP is 10.0.1.20. Okay, so now we are connected to this private instance. Because we are using a private network definition list, hence we are able to connect to this private instance. Now, what are we going to do? Before I perform any further steps, let me show you one thing. Virtual Cloud Network, Demo VCN. This route table has a route out to the internet through the NAT gateway. And therefore, when I'll try to install CLI, it will work because my route table has NAT gateway entry. So this concludes the first part of this demonstration on Service Gateway. In the next part, we will look at how we can install OCI CLI on top of compute instance and then connect to object storage service. So thanks for your time. Welcome to this second part of the demonstration on Service Gateway. Let's get started. So let me now install the OCI CLI. Okay, so now this is complete. So what I will run now is OCI setup config. Now it is going to ask me the location, press enter, that's the default. It's asking me the user OSID. Okay, so this is the user OSID. Then it's asking me for tenancy OSID. Now it is asking me to select the region. So I am in the US Phoenix region, so I will type 50. Now it is asking me, do you want to generate a new API signing RSA key pair? Yes. So this, I'm okay with this directory. and let me provide it a name, Samvid. So now that key is generated. So if I look at the present working directory, okay, so Samvid underscore public dot pem. So let me just open it. So I need to copy this and I need to go to my profile and I will be adding it an API key, and then I can paste the public key. Okay, so now this is done. So now we will be able to interact with the object storage service. And remember, I am inside the private instance. Let me show you the contents of this bucket. This bucket is actually empty, but we will try to upload some data in this object. Now, before I do that, I will make a couple of changes. The first thing that I would do is I will remove the NAT gateway entry from the default route table, because we don't want to hit the object storage service through internet. We want private communication. But even before that, let me show you. This way you will learn better. I'll create a test file. Okay, so this is the test file that I created. And now what I will do, you see that the bucket name is demo bucket. So I will fire a command and I will explain you what that command looks like. OCI object storage object put the bucket name is demo bucket and the file name is test.txt. If I try to enter this command, now nothing is going to happen because in the route table we don't have anything. So let me go ahead and add the route rule. The target type is service gateway. The destination service is OCI Phoenix object storage. The target service gateway is service gateway, and click on add route rules. Now in the route table, we have added this particular route. So what do you think? Now, is it going to work? It works. So if I go ahead and refresh this bucket, I will see that this text file is now added to my bucket. After we added the service gateway, you see the private subnet has only one route in the route table, and that is for service gateway. There is no internet gateway, there is no NAT gateway. But we are able to upload this particular text to my object storage bucket. If I try to ping let's say oracle.com, I will not receive any response. Why? Because it's not connected to NAT gateway, nor is it connected to internet gateway. So I hope you enjoyed this demonstration. Thanks for watching. Hello, let's talk about public subnet. Now, in the previous lessons, we have discussed that there are two types of subnets that are possible inside the VCN. The first is public subnet, and then we can also have private subnet. Let's get started. So this is what you get to see when you are creating a public subnet inside the OCI console. Under subnet access, you should select public subnet, and that is actually the default choice. And when you select public subnet, because ultimately the instances will be placed inside the subnet. For example, this is the subnet, and we can have virtual machine instances, let's say VM1, VM2. So virtual machines will be deployed inside the subnet. And the moment we create a public subnet, we are basically giving a facility or a feature that allows us to assign public IP addresses to the virtual NIC of these instances. If you don't select it as public, then you will not be able to assign a public IP address to these instances. So this is something that you need to understand. So it allows public IP addresses for the instances that will be deployed inside or created inside the subnet. Right? So public IP address actually is allocated to the instance virtual NIC. And we have been talking these concepts in the previous lessons that we can use route table to add a route out to the internet, right? 0000/0, and the target is internet gateway. And what we need to do, let's say we created a public subnet, then we deployed a virtual machine instances, enabled public IP address for the VNIC, then associate this subnet with the route table having this route entry. Now, one more thing that you need to take care is you need to open up security rules, network security group and security list. Ideally, subnet is associated with a security list, and then you can basically communicate with the internet. Just to help you visualize graphically what I explained you in the whiteboarding, there is a VCN. There are two subnets, private and public. Our focus is on public subnet. This is the VM instance where we have enabled public IP address. We have also created an internet gateway, and we are basically having a route out to the internet through the internet gateway because the destination CIDR is this. So this marks the end of this lesson where we mostly focused on public subnet. In the next lesson, we'll talk about the private subnet side of the things. Thanks for watching. Welcome to this demonstration on public subnet. Let's get started. So I'm inside the OCI console, and I can see that there are two VCNs. So we will work with the demo VCN for this demonstration. Click on demo VCN, and then I can see the different types of gateways created: internet gateway, NAT gateway, and service gateway. And I can also see the default route table. But if I go to subnets, I'm not able to see any subnet. So I will first create a public subnet. Let me do that. I'll give it a name, public subnet. I'm okay with this compartment. The subnet type is regional, which is the recommended option. I'll provide this CIDR as the CIDR for this particular public subnet 10.0.1.0/24. This is basically the subset of the VCN CIDR. Now, this is important. This has to do with the subnet access. In this demonstration, we are going to create a public subnet. So public is actually the default choice. And what happens is, if you create a public subnet, because we know inside the subnet, we can have our instances. So if this is our subnet, we can have instances within the subnet. And these instances, they can have public IP addresses. And I'm going to show you these after I provision this public subnet. So I'll select public subnet and rest everything remains the same. Click create subnet. You see this is provisioning now. Okay, so now you see it is available. Now just having public subnet is not enough. Let me also make changes in the route table. So default route table, I am going to add the route rules. The target is internet gateway and this is the destination CIDR, internet. I already have an internet gateway created. I will add the route rule. Okay, so that's it. Now, because we have a public subnet, if I go to compute and try to launch a virtual machine instance, let me click on create an instance. So this is the name of the compute instance, public subnet demo. Compartment is fine. Rest everything is default. Now here, it's asking me to select existing virtual cloud network. So I'll select demo VCN and all we have is a public subnet. So I'll select that. After this, you get two options. One is regarding the private IPv4 address. The second option is regarding public IPv4 option. Note that because we have created a public subnet, hence we are getting an option for assignment of public IPv4 address. Okay, so I'll not create an instance, but I wanted to show you how this looks like. In the next demonstration, when we will talk about private subnet, you will see that this option will be grayed out. This marks the end of this demonstration on public subnets. Thanks for watching. Welcome to this lesson. Now we will talk about private subnets that is created inside the virtual cloud network. When you are creating a subnet inside the virtual cloud network service, you get two options when it comes to subnet access. So the first option is you select a private subnet. The second option is you select a public subnet. We already discussed this in the previous lesson. So our focus in this lesson will be on private subnet. So when you create a private subnet, let's say you created this subnet and this is actually private. So what would happen? When we are deploying virtual machine instances inside this particular subnet, all this VM would have in terms of IP address is the private IP address. So it will not have public IP address. Why? Because the moment you create private subnet, it is going to prohibit public IP addresses for the instances that are going to be created inside this subnet. So only private IP addresses. Now, the next question that should come to your mind is, what if this VM wants to interact with internet? or maybe with on-premises environment. So what are the solutions that we have for this particular use case? To facilitate internet connectivity to virtual machines deployed inside a private subnet, we have already discussed, we have something called NAT gateway. And to facilitate communication with the on-premises environment, we have another gateway, which is DRG. And DRG stands for Dynamic Routing Gateway. We have a discussion focused on Dynamic Routing Gateway in the upcoming lessons. But for now, you just make a note that you can use Dynamic Routing Gateway to communicate with your on-premises network or on-premises environment. So it does not allow public IP address for the instances. The instances are going to have only private IP addresses that we already discussed. And we already know that the internet communication is going to be permitted by using the NAT gateway. We had a discussion on the NAT gateway in the previous lessons, very detailed discussions. So I am not going to spend time on it once again. But I will very quickly show you this particular architecture. Our focus will be this side. So here you see two constructs. One is NAT gateway. The other one is dynamic routing gateway for communication with customer data center, and NAT gateway for communicating with internet. So this is basically how the route table is going to look like for the private subnet. So this marks the end of this lesson. Thanks for your time and hope you are enjoying this learning experience. Hello and welcome to this demonstration on private subnet. Let's get started. I'll take you to the OCI console where you can see this particular VCN, demo VCN. So I'll go inside it. And then what you see here is there is a public subnet. So let's create a private subnet as well. So click on create subnet. I will name it private subnet. The compartment looks fine. The subnet type is regional. I'll provide a CIDR block. And this again is subnet access. In the previous demonstration, we selected public subnet. So now we will have private subnet. And if you select a private subnet, the instances that you will launch inside this private subnet that will not have public IP address, that will just have private IP addresses. And I will show you that when I launch a compute instance. So rest everything remains the default. Click on create subnet. I'll wait for the private subnet to be available. And then I will make the corresponding changes in the route table. Okay, so this private subnet is now available. So let me go to the route table. So I will name it private route table and add a route rule. The target type is NAT gateway. This is the destination CIDR, and I will select the NAT gateway that is already provisioned. Click on create. So this is going to create a route table, and along with that, it is going to add a route out to the internet through the NAT gateway. Now let me go to compute. Click on instances. Click on create instance. Private instance is the name. Okay with these all settings. I'll quickly go to select existing virtual cloud network, select demo VCN, and select existing subnet. Instead of public, this time I will select private subnet. So this is what you see. You get the option to provide private IPv4 address, but when it comes to public IPv4 address, you see that it is disabled. So you cannot assign public IPv4 addresses. And there is also a note that is provided because the selected subnet is private, therefore no public IP addresses exist in this subnet. Now the next question arises, how do you access these instances that are created inside a private subnet? I'm not going into the details, but there are two ways in which you can do it. First, by using a service which is known as OCI Bastion service. Second, you can also make use of private definition list. That's a feature of Cloud Shell. So this is a good to know information. And with that, we conclude this demonstration on private subnets. Thanks for watching. Welcome once again. So in this lesson, we are going to look at VCN security. So first of all, let's look at the ways in which we can control security for our virtual cloud network. And there are different strategies. The first strategy is we have this concept of public and private subnets. So you can designate a subnet to be private. We also have two constructs in VCN. I am putting it under the security rules category. We have security lists and network security group, which is NSG. So there are two constructs when it comes to security in VCN. Apart from that, you can also configure firewall rules directly on the instance. What we can also do is we can configure IAM policies, identity and access management policies, to control who can set up your VCN or subnet, or who can configure security list and network security groups. So that can also be done. In OCI, there is also a concept of security zones. Now, this is just to ensure that your networking resources, they comply with Oracle security principles and best practice. A security zone is always associated with a compartment. A security zone does not permit the use of public IP address. That is not permitted. So it allows only having private subnets. So these are some of the ways that can help you secure your network. Now I will give you a layman example that will help you understand the security rules even better. In the previous discussion, I mentioned that we have two constructs. The first is security list, and the second is network security group. Now, imagine there is a housing society and there are some row houses, house A, house B, house C, house D, something like that. This is a housing society, and then this is, let's say, the main gate for the housing society. And then each of these house also has a dedicated guard who is guarding the house. And there is a guard, is the main guard who is sitting at the main gate. Now, if there is a traffic, now in this case, traffic is a person because we are talking about housing society. Now, in order for traffic or the person to enter the housing society, this person needs to first cross this main gate, which means this person needs to be allowed by this main guard. And then let's say this person wants to go to house A. He has to be allowed by this particular guard as well. If you understand this, you will very easily understand what is a security list and what is a network security group. Replace the housing society with a subnet. Replace the individual houses with virtual machine instances. If you do that, this main guard you can replace with security list, and these all you can replace with network security groups. Why? Because security list is associated with a subnet, whereas network security group is associated with the VM instance NIC. Now let's go to the deck and reinforce what we have discussed. Now we have already seen this. I will not spend time talking about this, but we discussed all these strategies, how we can secure our network, be it with respect to having different kinds of subnets, configuring IAM policies, or defining network security group and security list, firewall rules, having route table, having different types of gateways, or configuring security zones. Then specifically focusing on the VCN security, you remember the layman example I mentioned. There are two virtual firewall features. The first is security list. This is basically the main guard who was guarding the society. And then network security group. This was the guard who was guarding the individual house. Now you may choose to use security list alone, network security group alone, or both can also be used. The next 2 points have to do with the number of security lists and the number of NSGs that can be associated. If you have a subnet, you can have up to 5 security lists associated with the subnet. That's the limit. And if you have a VNIC, you can have again up to 5 NSGs associated with it. And every VCN, just like in the previous lessons we discussed, when you create a VCN, there is a default route table. Similarly, when you create a VCN, it creates a default security list. So this was a kind of introduction video for VCN security. We are going to discuss network security groups and security lists in our upcoming lessons. Stay tuned. Thanks for your time. Welcome to this lesson on network security group. So let's get started. What is network security group or NSG? It is a kind of virtual firewall. Virtual firewall means we can define ingress as well as egress security rules. So in a way, in network security groups, we define security rules. And along with that, this is the first thing that we define. And the second thing that we also define is the VNICs, because this network security group is going to be associated with the VNIC of the compute instance. And it's not just compute instance that supports network security group. There are other resources like load balancer, mount target, API gateway. I'm just giving you a few examples. Apart from compute instance that supports network security groups. But these are the two things that you define in order for NSG to work. So now let's look at some more detail. I mentioned that it's a collection of ingress and egress rules. So let's first look at what an ingress rule is, and then we will look at what's an egress rule. Assume this is an instance. This is the virtual NIC. So this is where we associate the network security group. Now ingress rule. Ingress rule means ingress to the instance. See the direction of the arrow. And in case of egress rule, if we have the instance here, this is the VNIC egress rule. This is egress rule. That means the direction of the arrow will point out from the instance. So what are the things that needs to be defined in ingress rule? In ingress rule, the traffic is coming from outside. So we have to decide which traffic is allowed inside the instance. So for that, we define the source type. From which source is the traffic coming? So source type. Now there are three types of source that are supported in an ingress rule for NSG. We can specify a CIDR block. We can also specify a service, for example, object storage service. And so we can also have NSG as one of the source types. Now, depending on the source type, we have to provide the source CIDR or source service or source NSG. Then the IP protocol, and there are different types of protocols that are supported. For example, just to name a few, RDP, SSH, ICMP. Then there is source port range. This is optional. And the destination port range is also optional. It will get automatically populated depending on the IP protocol that you select. So these are the things that you define when it comes to ingress rule. Same is the case with egress. In the egress rule, you need to define the destination type. And same like ingress rule, it can be CIDR, service, or NSG. Then the destination depending on which destination type you are selecting. Then you need to also provide source port range and destination port range. These are again optional. So this is how you can define ingress and egress rules for a network security group. And after you configure these rules, then you can decide, let's say this is your NSG, then you can decide to which all instances or which all VNICs you want to apply that NSG to or associate that NSG to. Now the next discussion that I want to do is with respect to stateful versus stateless rules. So while creating ingress or egress rules, you have an option to specify the rule type, whether it is stateful or stateless. Now let's look at the difference. Stateful means responses are automatically tracked and allowed. So in stateful, fundamentally you are using connection tracking. And the way I will explain it is, let's say this is an instance, virtual machine instance, and then this is your internet. Let's say you defined an ingress rule for the destination port 80. The source is 0000/0. So the response traffic, the response for this request is automatically allowed if it is a stateful rule. So responses are automatically tracked and allowed. In case of stateless rules, you need to define egress rules in case you want the response to be allowed. So that is the fundamental difference between stateful and stateless rules. Now, another thing before I jump to the deck is one of the use cases of network security group. Let's say in your VCN, you have different types of resources. When I say different types, I mean resources with different security postures. For example, there might be a web tier. There might be app tier. Let's say in the web tier, there are 3 instances. In the app tier, there are 2. So when you are configuring network security groups, typically you will have the same NSG for all the 3 web tiers. Similarly, you will have another NSG for the app tier. And we have seen that when you configure the ingress or egress rules for a NSG, you can have the source type as NSG. So if you would like communication between web tier and app tier, let's say the app tier would like to receive traffic from the web tier. In the source for NSG2, you can have NSG1. So that is one critical point that I wanted to explain you. That marks the end of this lesson. Thanks for watching. All right, now let's move to the deck and revisit some of the concepts. So primarily, network security group is a virtual firewall where you can define ingress and egress rules. And in the whiteboarding, I have explained you for resources having the same security posture. For example, all the virtual machine instances in a web tier or app tier, you can basically create one network security group and associate it with all the resources that have the same security posture. But the condition for this is all the resources must be in the same virtual cloud network. Network security group basically consists of 2 items. The first is the set of VNICs to which this can be associated with. And the second is a set of security rules, which will include both ingress and egress rules. Apart from compute instance, there are other resources which also support network security group. For example, load balancers, mount target, API gateway, etc. So here in the architecture, you see there is a VCN and there are 2 different subnets. There are 2 virtual machine instances in subnet A and there is 1 instance in subnet B. And we have a total of 2 network security groups, the rules for which you can see in this particular table. So for network security group A, we have created a stateful rule. The direction is ingress. So the source is basically 0000, that means internet. The protocol is TCP and the destination port is 80. And what we have also done is we have associated the NSG A to this instance and this particular instance. And we have associated NSG B to this particular instance. So if we talk about this particular instance, anyone in internet will be able to perform an SSH to this instance because we have allowed port 22. When we create a VCN, a default security list is created, just like a default route table. But when we create a VCN, a default NSG is not created. So if you would like to use NSG, you have to go ahead and create an NSG and define the security rules inside that NSG. Now, in the discussion in whiteboarding, I mentioned that you can have CIDR, you can have service, you can also have NSG as the valid source types when you are configuring the ingress rule. In case of egress rule, it is going to be the destination type. In case of ingress rule, it is going to be the source type. So this is what is being discussed here. But the criteria for this is both the NSGs must be in the same VCN. So you can control traffic between two different NSGs. Just like I mentioned, you can have a web tier, define one NSG for the web tier, define another NSG for the app tier, and then you can control the traffic between those two NSGs. We also discussed what is a stateful rule, what is a stateless rule. So very quickly to illustrate, you see here, this is an example. So there is instance A and then there is host B. We have created an ingress rule that allows port 80 from internet. Now, if this rule is stateful, the response traffic for this particular traffic is going to be automatically allowed. So you don't need to explicitly create an egress rule. So it automatically allows response traffic. And that also implies that you would like to use connection tracking. So this is your stateful rule. In case of a stateless security rule, the same example, but here the rule is stateless, and therefore we have to explicitly define this egress rule. That means the destination is 0000, TCP, the source port is 80, and the destination port is all. Then only the response is going to be allowed. So here you would not like to use connection tracking. So what is the use case for a stateless security rule? When will you use it? So it is recommended if you have a high volume internet facing website, and the typical scenario is for HTTP and HTTPS traffic. That marks the end of this lesson on network security groups. Thanks for watching. Welcome to this demonstration on network security groups. So first of all, I will explain you what I will perform in this demonstration. You recall that when we create a VCN manually, then it creates components like default route table, default security list, and DHCP options. But it does not create a default network security group. So in this demonstration, the first thing that we will do is we will create a network security group. We will also create an ingress security rule. And this security rule is going to allow the source, that means anything, the protocol is going to be TCP, and the destination port is going to be 80. And the third part of this demonstration is where we will associate this network security group to the virtual machine NIC. And after that, we will do the testing. So to summarize, we will have a VCN that is already created. There is also a public subnet which is already created. But what we don't have is a NSG. So we'll create NSG. Then we will add a rule, just like I explained. Then we will install Apache Web Server on a compute instance. And then we will try to access the web server from the internet. So let's get started. I'll take you to the OCI console and we'll work with this particular VCN, which is demo VCN. You see there are two subnets, private public. We'll work with public subnet, but under resources, you can see that there is already a security list that is created, which is default security list. Here you can see that there are some default rules. I will go back and I will go to network security group. And you see there is no network security group that is created for the VCN. Click on create network security group. I will call it demo NSG. I am okay with the compartment. I'll click on next. And then I'm going to add an ingress rule, which is going to be stateful. The source type is going to be CIDR. The source CIDR is going to be internet. The protocol is going to be TCP and the destination port is going to be 80. I'll click on create. So the NSG is now created. Under resources, you can see the security rule that we added. And if I click on Linux, you will not be able to see anything because as of now, this demo NSG is not associated with any VNIC. So let me go ahead and create a compute instance. I'll click on create instance, demo NSG instance. Compartment is fine, placement is fine. Okay with security, image and shape. Coming to the primary network, I will select demo VCN and I will select public subnet. I'm also going to let OCI automatically assign private IP address and public IP address. I will also add the SSH keys. I already have the key pair, so I'll just add it. The rest, everything remains the same. Click on create. So once this instance is available, we will connect to the instance and we'll install Apache Web Server. So let me launch Cloud Shell. Meanwhile, this instance is getting provisioned. Okay, so I'll type yes. So now I am connected to this instance. What I will do now is I will install Apache Web Server. So let me just paste these commands. Okay, so I will also allow this service in the local firewall. And now, okay, so this is what I have put in the index.html file. This is a compute demo test page. So if I copy the public IP address and enter it in the browser, you see that nothing is going to work now. Why? Because as of now, we have not associated this network security group that we created with this primary VNIC. And you see it says none. So what I will do now is I will click on edit and I'll select the NSG that we created, which is demo NSG. Click on save changes. So now the network security group is demo NSG. So copy this public IP address again and just refresh this page. You will see that this is now working fine. That means the port 80 is now allowed. And why was this the case? Because we have associated this instance with a network security group. And if we look at the network security group, this has an ingress rule. So it is basically allowing the destination port range 80. Now, one question you might have is this VCN, this already has a default security list. But if you look at the rules for the default security list, there is no rule for destination port 80. There is one rule for destination port 22, but for 80, it's not there. And therefore, it did not work the first time. Let me show you one more thing. If I go to the VCN and I click on network security group, I click on this demo NSG, I click on VNIX. Now you will see that there is one VNIC that is listed here. This is the name of the VNIC, and this is basically the parent resource. So this marks the end of this demonstration where we looked at how network security groups work. Thanks for watching. Welcome to this lesson on security list. Let's get started. So just like network security group, this security list is also a common set of firewall rules. That means it's a collection of both ingress and egress security rules. But how is it different from a network security group? Well, a network security group is associated with a virtual NIC, whereas a security list is associated with a subnet. So if you'd like to apply the same set of rules to all the instances that are there in a subnet, the best way is to configure a security list and then associate it with a subnet. So it is applied to all the instances that are inside the subnet. So it consists of both egress and ingress rules that basically controls which traffic is allowed to come in and which traffic is allowed to go out of the particular subnet in question. Keep in mind that the security list is associated with a subnet, but ultimately it is enforced at the VNIC level. So in the graphics on the right, you see inside a VCN, there are three subnets, subnet A, subnet B, and subnet C. And we have created a security list and we have associated the same security list with all the three subnets. And in the security list, you see that there are two rules that have been added. One is egress and the other one is ingress. Both are stateful rules. So when you are configuring security for the VCN, you can use security list alone. You can also use network security group alone, but you can also use both security lists and network security groups. Now, one of the use cases of security list is that in case you would like to enforce a certain set of ingress and egress rules for all the instances or VNICs that is there in a VCN. So the best way for you is to put all those rules or define those rules in security list and then simply associate the security list to all the subnets in the VCN. That way you can enforce the security rules to all the instances. So as you can see here, there is a subnet inside a VCN, and that subnet is associated with two security lists, security list 1 and security list 2. And the virtual NIC is also associated with NSG-A and NSG-B. Now, what happens if you apply multiple security lists or multiple NSGs to the same VNIC? So ultimately, the result is the union. So when you have both security list and network security group applied, then it's the union of all the security rules that you have defined in the security list associated with the subnet. Along with that, all the ingress and egress rules that you have configured in NSGs that is associated with the VNIC. And the guiding principle here is a packet or the traffic is allowed only if there is an allow rule in either security list or network security group. So if there is an allow rule in any of the constructs, then only the traffic or the packet in question is going to be allowed. There is one important point that I would like to discuss, and that is also one of the differences between network security group and security list. You remember when we discussed network security group, I mentioned that when you are defining an ingress rule, you can have the source type as CIDR, it can be service, and it can be the NSG itself. But in case of a security list, what are the source types that are possible? You can have CIDR, you can have service, but you don't have a security list. This is also one of the key differences between network security group and security list. All right, this marks the end of this lesson on security lists. Thanks for watching. Welcome to this demonstration on security lists. Let's get started. I'll take you to the OCI console, and this is the VCN. The first thing that I will show you is if I go to the security list, when I create a VCN, this default security list is automatically created for me. So if I click on the default security list, there are three rules in ingress rules, and there is one rule in egress rules. So let's talk about what these rules are. If you look at the first rule, this says allow TCP traffic on destination port 22, which is SSH, from this particular source. And so this first rule, this enables you to create a new VCN and a public subnet. Then you can create a Linux instance and then immediately use SSH to connect to that particular instance. You don't need to write or add any security list rules yourself. So this is the first rule. The second rule talks about allowing ICMP traffic type 3 and code 4 from authorized source IP addresses. And then this third rule also talks about enabling instances to receive connectivity error messages from other instances within the VCN. So this is allow ICMP traffic type 3 from your VCN CIDR block. So these are the three ingress rules. One thing that you will see is there is no destination port range 80 rule added here by default. So egress rules, This rule allows instances to initiate traffic of any kind to any destination. So these are the default rules that are created. If I go to my compute instance, which is already created and is currently associated with this particular network security group. So let me click on edit, remove it. I'll click on save changes. So currently I don't have any network security group associated with the VNIC of this instance. So I'll copy the public IP address and I'll paste it here. This is not going to show anything. Now what I will do, I will go back to my demo VCN and I will add a rule in the security list. I don't need to create an additional security list. I can use the default security list to add an ingress rule. So my rule is going to be stateful. This is the source CIDR TCP. The destination port is 80. That's it. Now, after adding this rule, if I go back and refresh this page, this time I will see that it works. So this marks the end of this demonstration where we had a look at the default rules in a default security list, and we also looked at how we can configure a rule to allow traffic from internet and reach to the compute instance.
Welcome to this module on IP management. In this module, our focus will be on IP addressing. We'll discuss the two types of IP address, public IP address and private IP address, and we will also understand how to use these IP addresses with respect to a virtual cloud network. I will also help you understand the differences between these two types of IP addresses. Next, I will talk about bring your own IP that lets you bring the public IP addresses that you own into OCI. We'll conclude the discussion of this module with the discussion of IP pools. So let's get started.
Welcome to this lesson on overview of IP management. So now we are starting the discussion on IP management, and this is an overview lesson. So let's first talk about the two different types of IP addresses. The first is private IP address, and then there is public IP address. Let's first focus on private IP. So what is the use case of a private IP address? Let's say this is a VCN. Inside the VCN, we have a private subnet. Inside the private subnet, we have a virtual machine. And this virtual machine has got a VNIC which has private IP address assigned to it. We were talking about the use cases of private IP address. The first use case is this particular instance. This instance can talk to other instances in the same VCN. There might be, let's say 7, 8, 10, whatever the number of instances in the same VCN, might be in a different subnet, but the condition is the instances should be in the same VCN. So the communication can happen through private IP address. The second scenario is that of peering. Peering happens when you connect two different virtual cloud networks. So this peered VCN, they can exist in the same region. They can also exist in different regions. So in case of a peering, the instances talk to each other using private IP addresses. So that's the second use case. The third use case is this particular instance, it can also talk to other hosts in on-premises network. This typically happens with the help of either site-to-site VPN connection, or we also have another service which is known as Fast Connect. There also the communication happens using private IP addresses. So these are some of the use cases of private IP addresses. Now let's talk about some specifics. Now I am drawing an instance. Now this instance can have a primary VNIC, virtual network interface card. It can also have secondary VNIC. So instances can have primary NIC and secondary NIC. Now this primary VNIC is going to have a primary private IP address. You can have one primary private address in a primary VNIC. Similarly, this secondary VNIC, it can also have a primary private IP address. So one denotes the number of primary private IP address. There can be only one primary private IP address, both for primary VNIC and secondary VNIC. Now comes the interesting part. You can also have secondary private IP address, and that can be 32. So you can have 32 secondary private IP addresses. Similarly, you can have 32 secondary private IP addresses in a secondary VNIC. So the point to be noted here is that if there is a secondary VNIC, it also receives a primary private IP address. And whatever IP addresses we are talking about, all these private IP addresses, they can have a public IP address assigned to it at our discretion. So in a way, a VNIC, it can have a maximum of 33 private IP addresses, and I'm talking about IPv4 addresses here. Out of 33, one is primary and 32 is secondary. So total of 33 private IPv4 addresses in one VNIC. So now let's talk about public IP address. So what is the use case of public IP address? Basically, it is reachable from internet. It is reachable from internet. And in OCI, there are some resources, for example, NAT gateway. This resource is designed to be directly reachable from internet, and we have seen that in previous demonstrations. And hence, this NAT gateway, it actually comes with a public IP address. Now, there are two types of public IP addresses in OCI. The first type is ephemeral. The second type is reserved. Let's do a bit of discussion on these two types of public IP addresses. So on one side, I will write ephemeral public IP, reserved public IP. Let's do a comparison of these two types of IP addresses. First, let's try to understand what is what. Ephemeral, the word ephemeral means something that is not permanent. So it is basically a temporary public IP. And this reserved public IP is something that is persistent. We have an instance. This instance, let's say, is associated with a public IP address which is ephemeral. So what happens if we delete the instance or terminate the instance? This public IP address goes away. So what it also means is that this ephemeral public IP address exists for the lifetime of the instance. Whereas in case of a reserved public IP, let's say this VM instance is now associated with a reserved public IP. Now, in this case, even if the instance gets terminated, this reserved public IP address is going to exist beyond the lifetime of the instance. What it means is you can reassign this public IP address to another instance whenever you like it. So this is the difference between ephemeral public IP versus reserved public IP. One more difference that you should understand here is that this ephemeral public IP, these can only be assigned to a VNix primary private IP. We had a discussion on this few minutes back. What is primary private IP and what is secondary private IP? In case of reserved public IP address, it can be assigned to either a primary private IP or a secondary private IP. So this is another difference. All right. This marks the end of this lesson, and in the next lesson, we will discuss the deck for IP management overview. Thanks for watching.